Hello class, and welcome to the EMS Vehicle Operator Safety course. And in this lesson we will talk about vehicle inspection and maintenance. We'll cover such things as vehicle inspection and preventive maintenance, the complete vehicle inspection of the exterior and the interior, how mechanical components and how systems of the ambulance function, the huge value there is in road testing, and how to respond to vehicle problems. Like always, I've mentioned earlier that our exam questions are mapped to the learning objectives. So let's take a look at the learning objectives and see what we need to understand by the time we get done with this lesson. At the conclusion of this lesson class, you should be able to explain the importance of vehicle inspection and preventive maintenance. You should be able to demonstrate how to perform a complete vehicle inspection of the exterior and the interior. You should be able to explain the function, inspection, and maintenance procedures for the various mechanical components and systems of your emergency vehicle. You should further be able to explain how to respond appropriately to vehicle problems and discuss the value of road testing for vehicle performance. And finally, class, you should be able to describe relevant standards and certification programs for vehicle inspection and maintenance. All right, let's take a look at this scenario, class. Now, Kelsey moved the ambulance out of the bay for the morning checkout and noticed a pool of fluid on the bay floor. She noted the presence of fluid on her checkout sheet and reported the problem to her supervisor. The supervisor asked what color the fluid was, but Kelsey didn't know. She returned to the bay area to look, but someone had already mopped up the bay and cleaned up the fluid. The supervisor explained the color is an important clue to determine what type of fluid is leaking. For example, motor oil is typically golden to black in color. Antifreeze is typically green and watery. And the transmission fluid is red with an oil-like consistency. Some of the things I want you to consider, class, as we move forward with this lesson. Do you have a clear list of reasons for when and how an ambulance can be taken out of service for mechanical problems? The second one, what are your standard operating procedures and training for checking the mechanical elements of an ambulance? And did you know, class, that as an operator, you need to ask yourself, what liability do you hold for the mechanical function of the ambulance? All right, so do you have a clear list of reasons for when and how an ambulance can be taken out of service for mechanical problems? This should be addressed in your orientation when you start to work with your EMS agency. The second question I asked you to think about, what are your SOPs and training for checking ambulance mechanical elements? Again, this should be part of your standard operating procedures. You should have a thorough understanding of this before you start operating the ambulance as a driver. And finally, what liability do you hold for ambulance mechanical function? And again, this should be spelled out in the jurisdiction, in the administrative code, and in the standard operating procedures for which agency you're working with and the area that you're working in. Now, most services, class, have a daily shift vehicle checklist. As an emergency vehicle operator, it is your responsibility to check the vehicle and report deficiencies. Training should include how to check these following items and what to look for and what to report. Now, on the exterior of the ambulance, you need to check that the body is clean and free of damage. Look at the tires, class. Note any uneven wear. Check the air pressure. The proper inflation is determined by the vehicle manufacturer, not the tire manufacturer. Next, check that all the external lights are working. To safely check emergency lights, make sure the engine is running and the brakes are set so high idle can be employed when the extra power is needed to light up the emergency lights. Now, on newer vehicles, they have both response and on-scene emergency lighting. Certain lights will shut down when placed in park and turn on when in drive. Have a second person with you to check the lights while the emergency vehicle operator places the vehicle in drive and his or her foot is on the brake. You also need to check that all doors open and close properly and lock. Examine the windows for cleanliness and cracks. Check the windshield wipers to make sure they're intact and not worn, and check the exhaust system to ensure that there's no leaks. Now let's talk a little bit about the interior inspection. An inspection of the vehicle's interior will involve the following, class. You'll check that the operator compartment is clean and neat. You'll check that all radios, public address systems, and sirens are working properly. You'll check that the fire extinguisher or extinguishers have not expired. You'll check that the seat belts and restraints are working properly. You'll check the mirrors and make sure they're properly adjusted. Check that the window and the mirror heater controls are working properly. You'll also look at the equipment for basic maintenance, such as jumper cables that should be kept on the vehicle. A basic set of tools may be used for basic repairs to the vehicle and may allow you to help someone else in need. Next, take a look at the gauges on the dash. You need to examine the following gauges. Look at the fuel. It should be full, or it should be filled in accordance with the standard operating procedures of your EMS agency. Look at the oil pressure gauge. Check the air pressure gauge if you have a unit that has air brakes. Look at the coolant temperature. Examine the speedometer and the odometer. Look at the hour meter. Look at the tachometer, and look at the voltmeter. I want to make a note here, class. Any warning lights, that come on the dash, you need to follow your department SOPs when you're addressing them. Also, make sure you have a clear understanding of the operating manual for the unit that you've been assigned, because the operating manual will let you know what the appropriate oil pressure would be, what the appropriate coolant temperature is, and whether or not, and what is the appropriate amount that can register on your voltmeter. Okay, let's review a safety pointer here. The vehicle inspection checklist are legal documents, class, that can be subpoenaed, so take your documentation seriously. Review the location of all emergency equipment. Most people do not realize how important it is to actually check all the items on the checklist until they break down with a critical patient on board. Can it be considered negligence to simply check the boxes on the sheet without performing an effective inspection? If the patient is harmed by the carelessness and the falsification of your pre-trip form, you can bet there will be lawyers looking at every sheet you have filled out. What if you were going on an airplane and you saw the pilot just put check marks on the inspection sheet without actually inspecting the plane? You have lives in your hands every day you operate that ambulance, and helping them involves making sure that your ambulance gets them to a definitive care facility. Okay, class, the form in front of you is a sample form. You are encouraged to substitute the actual form used by your EMS agency. The emergency vehicle operator needs to document that the vehicle and all of its systems are in proper operating condition. Shown in front of you is a sample page from a form used for this purpose. You need to know the locations of the oil, the transmission fluid, the power steering fluid, the brake fluid, and belts under the hood of a typical ambulance, especially the one that you are assigned to drive. The engine is heavy duty, so it can run for a long period of time and has power alternate systems. The engine compartment should be clean. Belt should be snug and not worn, and look and make sure there's no cracks or cuts in the belt. Hoses should be properly attached and show no signs of leakage. Check the oil level. When checking the oil, the engine should be turned off for at least 5 minutes. If you need to add oil, use only the brand and type your service provides. Make sure you check the coolant level. When checking the coolant, the engine must have been off for at least 5 minutes to avoid a serious burn injury. Never open the radiator. Coolant systems usually have an overflow or fill reservoir to add coolant to if necessary. Perform an oil check and adjust levels as needed. Always follow your standard operating procedures and document the vehicle check and any adjustments made or any fluids that are added. In addition to looking at the oil level, check the oil, check the color of the oil, smell it to see if it's burnt. See if there's any liquid or milky substance or water in the oil as well. All of these indicate a mechanical failure. Now I want to take a look at a real life scenario, and then I want to lead a discussion and I'm going to ask some questions and have you start thinking about them. Okay, during the morning checkout class, Danny was behind schedule and completed the inspection sheet in a hurry. Later that day, another EMT, Carl, was responding to a call and was unable to contact anyone on the radio. He had to resort to the unit's cell phone to get in touch with the hospital. After wheeling the patient into the hospital on the stretcher, he returned to the vehicle, but the engine would not start. He tried to turn the unit's headlights on to determine whether there was a problem with the battery and discovered that the headlights weren't working either. He opened the hood of the unit and noticed the alternator belt lying beneath the radiator. The alternator belt could have been easily replaced if only Danny had done a thorough vehicle inspection. Let me ask you a question, something to think about. Do you ever hurry through your inspections? I hope not. I hope you follow the sheet and do a very thorough pre-trip inspection of your unit. Your life and the life of others will depend on it, and you as the driver will be held accountable in a court of law for the vehicle inspection of that unit. Okay, are under the hood inspections part of your required daily activities? Absolutely. As you found out in this scenario, if they would have done a thorough pre-trip, he would have noticed that the fan belt had been cracked or broke or was about ready to come off the alternator. But because of that, okay, the other crew that took the ambulance is now broke down and has a dead battery. Also, you need to ask yourself, are you trained on what to look for? If not, okay, or you don't feel comfortable, you need to ask your field training officer or your partner, or this should be part of your orientation for the unit that you're going to be assigned to. Remember, if you're driving, the law holds you accountable. Be knowledgeable of the electrical system in your vehicle and follow your manufacturer's recommendations for inspection. The electrical system provides all electrical energy for vehicle operation and takes on heavy demands. The alternator produces the current. It is powered by an engine-driven belt. Batteries store the energy to start the vehicle and provide limited backup. Inverters convert DC to AC to power items such as a suction unit or a cell phone charger. If you need to jumpstart your vehicle class, be familiar with the procedure and turn off all electrical loads. Most ambulances have automatic transmissions. Some will require checking the transmission and power steering fluids. The transmission fluid is checked with the vehicle running in park, and the power steering fluid is checked with the vehicle turned off. You need to follow your service's SOPs, standard operating procedures, on filling these fluids if found low. Now, the types of brakes and the braking systems that must be maintained include drum brakes, disc brakes, air brakes, and an anti-lock braking system. Most newer ambulances class have a see-through brake fluid system. If it is low, you'll have to notify your supervisor. The inspection of mechanical brake system parts is done by your service's mechanic on a regular basis. All right, let's talk a little bit about drum brakes, which is the one pictured on the left of your screen. These brakes have a circular wheel hub with two semicircular brake shoes. When the brake pedal is depressed, a piston pushes the brake shoes against the brake drum, slowing the vehicle down. Imagine you are in the middle of a cylinder that is spinning around you. Now, imagine trying to stop it by putting your hands against it and pushing as hard as you can to get it to stop. That's what drum brakes do. This type of braking system isn't as effective as disc brakes. This type of braking system generates a lot of heat and causes brake fade quicker than with disc brakes. Take a look at the disc brake. That's the one that's pictured on the right of your screen. These brakes have a disc that rotates with the wheel and calipers that squeeze shut on it when the brake pedal is depressed, which in turn slows the vehicle. Imagine a disc spinning in front of you. You are standing at the edge of it, and to stop it, you must press your hands together with the disc in between them. You would find that it is easier to stop the disc than a cylinder in a drum brake. Disc brakes are more effective in stopping a vehicle faster because it takes shorter brake distances than are the brake drums. Disc brakes allow for newer technology such as anti-lock brake systems and traction control to be added. Both work off a hydraulic fluid that is forced through the system and squeezes the piston or caliper and causes the brakes to grab the drum or the rotor. Air brakes have the same task as hydraulic brakes, but work a little bit differently. Unlike the hydraulic brakes, air is forced into the system and keeps the brakes from grabbing the rotor. When the air is released, nothing holds the brakes back and they engage, grabbing the rotor and stopping the vehicle. When the hydraulic brakes lose fluid, the vehicle has lost brakes and cannot stop. When air brakes lose air, the spring brake engages and the vehicle stops immediately. Air brakes should be tested daily by performing the ALSAPS method, which is air brake leakage test, the low air warning test, the spring brake test, the air compressor cutoff test, the parking brake test, and the service brake test. If the vehicle has air brakes, it's going to be important to perform these tests at the beginning of every shift. If your service has vehicles with air brakes, learn how to properly do these simple tests. If you look in the class notes that I posted on Canvas class, you'll see that I gave you a step-by-step process on how to conduct the air brake check. Air brakes should be tested daily by performing the ALSAPS method. And again, which is the air brake test, the low air warning test, the spring brake test, the air compressor cutoff test, the braking test, and the service brake test. If the vehicle has air brakes, remember it's going to be important to perform these tests at the beginning of every shift. If your service has vehicles with air brakes, then look at the sheet that I gave you. Okay, because it has all the state standards on the amount of air that can be lost in a given minute, within a minute. Okay? Let's talk a little bit about the tires. We need to check for proper inflation, adequate tread, and any signs of wear and cracks or cuts. Check it with a working tire gauge. Now, I use ICD as a mnemonic to help me remember. I for inflation, C for the condition of the tire, and D for the tread depth. The manufacturer's inflation pressures are on the sticker on the inside of the driver's door. Make sure you use the vehicle manufacturer's recommendations on tire pressure and not the tire manufacturer. Remember, we talked about this in previous lessons or earlier lessons, that the minimum tread depth on the front tires should be no less than 4/32 of rubber, and the minimum tread depth on the rear should be no less than 2/32 of rubber. Tire pressure tags can typically be found on the inside of the driver's door as pictured on your left up here. Make sure you check the tire pressure regularly, which is how you do it on the right, as you see the EMT on the right checking the air pressure. It is extremely important, class, to regularly check and maintain proper air pressure. Proper tire pressure is based on the vehicle manufacturer, not the tire manufacturer. The tire pressure should be checked when the tires are cold. That's when the vehicle has been sitting for a while. A drop of just 10% of tire pressure is enough to negatively impact the fuel economy. An example, 32 psi times 10%, that's 3.2 psi loss of air. A drop of just 20% of the tire pressure is enough to negatively impact handling, cornering, and stability. As an example, 32 psi times 20% loss is 6.4 psi loss. This tire may not look or feel flat, and yet is extremely dangerous. Now, when your tires are not properly inflated, they distribute the heat evenly from the road friction. Okay, let me back up and repeat that. When tires are properly inflated, they distribute the heat evenly from the road friction. They have good traction, providing good handling, cornering, and stability. They have the same surface area of the road contact as a sheet of paper folded in half. This is known as the footprint or the contact patch of the tire. All right, there is the contact patch of the tire. Okay, and that's what creates the friction to keep the car or the vehicle on the road. The proper tread depth ensures you have plenty of traction. All right, again, know what the vehicle code says. No less than 430 seconds on the front, no less than 230 seconds on the back. Your EMS agency may have stricter guidelines than this. Now, when tires are underinflated, they don't go flat. They actually pucker inward, creating a space between the tire and the roadway. Okay, they lose surface area of the road, only riding on the two sidewalls of the tire, which are the weakest part of your tire. The sidewalls absorb all the heat from the road friction, which will lead to a blowout. The tire shown has very poor traction, providing very poor handling, cornering, and stability. Now, how do tires hold in the rain? They should be safe when driving on a wet surface. And as an example, rain-soaked roads, puddles, and deeper water. The weight of the vehicle and the tread pattern on the tires keep the tire connected to the road. Tread patterns or grooves and sipes, grooves on the outer edge, help evacuate water from under the tire, allowing it to stay connected to the road. So then why do tires hydroplane? Tires lose traction as a result of worn or poorly treaded tires that can no longer evacuate water effectively. When tread wear has dropped below a minimum standard determined by the manufacturer, wear bars start to become pronounced and are visible. Wear bars, when even with the surface of the tire, indicate no tread pattern left and the tire becomes unsafe. Suspension systems should be inspected by a mechanic. The heater and air conditioner should be able to maintain 68 to 78 degrees Fahrenheit in the patient compartment. The stretcher mount should be working properly. The exhaust system should be intact. Some EMS services have a carbon monoxide monitor to check. Along with the exhaust systems, one should check the door seals. A rule of thumb is to close the door on a single piece of paper. If you can pull it through, then the seal isn't airtight and you could be letting fumes into the compartment. Try to maintain a temperature of 68 to 78 degrees Fahrenheit in the patient compartment. If the ambulance is too hot or too cold, it could affect the patient's condition. Regular inspections and servicing of the vehicle help to reduce potential equipment downtime and reduce costs. It is more economical to schedule servicing than experience costly breakdowns. Scheduling depends on the severity of the problem and safety to the vehicle. For example, a cut in a tire or brake issue is a high priority. Non-critical items can be repaired during regular repair appointments. Some services include road performance in required inspections. Is the steering wheel properly aligned and does it turn smoothly and accurately? Are there any unexpected noises? Is the brake pedal firm and does the vehicle slow per pedal pressure? Do brakes stop the vehicle evenly without pulling to either side? Does the vehicle accelerate with smooth engine operation and no skipping? Again, these items that are on the screen in front of you, class, are inspected during an actual road test where you take the vehicle out for a quick road test. Occasionally, an EMS vehicle has a mechanical problem or failure while it's in service. Be prepared to move the vehicle to the side of the road and notify dispatch immediately. Make sure you use your four-way warning lights and carefully place flares or safety triangles as prescribed by the vehicle code. If you are in a dangerous position, notify the police right away. If you have a patient on board, call for another ambulance to transport the patient to the hospital. If your vehicle is on fire, you must rapidly assess the situation and take actions to maximize the safety of others and your safety and the safety of others. Your main concern is to move yourself and the patient away from the vehicle. Always, class, and I repeat, always write up any issues before you end your shift. Don't leave an issue for the next crew to deal with. It may keep them from being able to respond to a call. Now, class, there are several guidelines and organizations that different EMS agencies refer to help manage their business. One of them is NFPA 1071, which is the standard for emergency vehicle technician professional qualifications. All right, this is for mechanics. And that way they have one set of guidelines for the whole across the country. So if your EMS agency adopts the NFPA 1071, then you can rest assured that he's met certain training criteria and is competent to work on your ambulance. Next is NFPA 1911, and this is the standard for pre-trips, okay, for inspections, maintenance, testing, and retirement of in-service automotive, fire, and EMS apparatus. Next is NFPA 1917, which is the standard for automotive ambulances, which describes what should be in an ambulance, defines what's in an ambulance, defines the different types of ambulances. Next is the Emergency Vehicle Technician Certification Commission. And then finally is the Automotive Service Excellence. So your EMS maintenance shop should be ASE certified and should have their mechanics carry the Emergency Vehicle Technician certification. Proper vehicle maintenance will help ensure safe winter driving. Vehicles can overheat in the winter and in warm weather because the engine works harder. All right, let's take a look at this scenario here. Okay, so look at the picture. Both vehicles are identical except for one glaring issue. Okay, the right vehicle has bald, underinflated tires and worn brakes. Okay, I'll just throw something else in. Or the right vehicle has additional equipment that was not meant for this vehicle, causing it to be excessively overweight. Now, regardless of what scenario that you choose, the actions of the driver are not factored in. This section is strictly about the performance of the vehicle once the driver has stepped on the brake. All measurements are dry. Okay, all measurements here, when I say measurement, I'm talking about stopping distances, are on dry, level asphalt. Okay, this would be the scenario where the ambulance is overweight, the one on the right. Okay, in this scenario, both vehicles are traveling at 30 miles per hour and hard braking is applied at the limit line. The braking distance will be measured. What do you think the outcome is going to be for the one on the right? The vehicle to the left, which is the good vehicle, stopped within the specifications of 42 feet. The vehicle on the right, which is the problem vehicle, stopped outside of its specifications at 52 feet. Now remember, we talked about this earlier. As the speed increases, so does the braking distance. A distance of 10 feet can be the difference between being in a collision or avoiding it. Let me ask you a couple questions. As the vehicle on the right enters into the zone where traffic is approaching from the right, how is stopping time affected for motorists approaching from that side? Okay, here's my answer would be the problem vehicle is now entering into the path of approaching vehicles, okay, that may not be able to stop in time. The other question I have looking at this, what other handling characteristics can be predicted with these types of issues? Well, my answer would be braking, steering, cornering. Rollover is more likely with the problem vehicle because it's heavier and has a higher center of gravity. Okay, class, let's summarize this lesson 5 here on pre-trip inspections. Let me review a couple of points here with you. Now, proper vehicle inspection and preventive maintenance are vital to the proper functioning of an emergency vehicle. As a vehicle operator, you must know how to perform a complete vehicle inspection of the exterior and the interior. Understand the function, inspection, and maintenance procedures for the mechanical components and systems of your emergency vehicle. Also, class, understand how to respond to vehicle problems. All right, this concludes our lecture on Lesson 5, Pre-Trip Inspections of Your Ambulances. Please do not take this duty lightly. Okay, if you are assigned an ambulance, I want you to walk away from this lesson remembering that the law holds you accountable, okay, and responsible to conduct a thorough pre-trip and only operate that ambulance when it's in a safe condition. As with any other lesson, class, if you have any questions after listening to this recorded lecture, please give me a call on my cell phone, or you can email me, okay, on my college email. Thank you very much, and I hope you've learned something from this lesson, and I will see you in class.